step onto the floor, the drawing pins which somehow got there prick you. What do you do then? Yes, you immediately move your leg away and scream out loud. Sometime later, when your dad is making your breakfast, you accidentally touch the hot frying pan. Once again, you yell in pain and simultaneously take your hand off from the extremely hot surface. What an unfortunate day, right? At some instances, we all wish that we should never experience pain. Just imagine what would happen if we never ever felt pain. It would be wonderful, wouldn't it? Frankly, it wouldn't be that great. Pain is not always bad. In fact, it's an indicator that some part of your body is in danger or is damaged and that it needs medical attention as soon as possible. So pain is actually like a gift to us. Who gives us this feeling of pain? Well, this is done by the central nervous system, which we will refer to as CNS. Now let us recall the painful event I just spoke to you about. Did you notice one thing in common that they shared? In spite of you not seeing the drawing pins or even the hot surface, your body immediately moved away from it. It means that even though you couldn't see the danger, your body managed to avoid further damage in no time. This is what we call a spontaneous reaction. Do you know what we call such a reaction in biology? We call this type of action as a reflex action. Who helps facilitate such a reaction? Is it the brain? Not really. The reflex action is the spinal cord business of the brains. Yes, the spinal cord receives the impulse and gives a quick reply to the muscles to take the next step. The brain is not involved in the actual processing of reflex action. Let's take a look as to what exactly this reflex action is. Recall the first incident when these drawing pins pricked you badly. Now when we step on the drawing pin, it pricks us here. This is sensed by the skin and the signal will be carried out by the afferent neurons to the spinal cord. Afferent neurons are those which carry impulses or information from the sensory organs to the CNS. Now let's have a cross-section of the spinal cord to understand it better. The sensory neuron will pass the information to the relay neuron, also called the interneuron, which is present in the spinal cord. This neuron you see here is the relay neuron. As the name suggests, it relays the information. It relays the information to the next neuron, which is the efferent or motor neuron. Efferent neurons are those which carry impulses or information from the CNS to the effector organs, which are our muscles in this case. These in turn make the muscles aware that it's time to move the leg. As a result, you move your leg away from the drawing pins, or in other words, just save yourself from the excruciating pain. So that's how the concept of reflex action works. Of course, the working is way more complex, but we've given you an overview of how it works. Wait, let us look at the path followed by the signal. Does it resemble any shape you know of? The signal traveled in a curved manner, forming almost an arc. This is why the flow of signals is also referred to as the reflex arc. We can also look at a very simplistic diagram to understand the concept of reflex action better. The stimulus is received by the receptor, which is the skin in our example. The impulse is transferred to the sensory neuron, which takes it to the spinal cord. Here in the spinal cord, we find a relay neuron, which is the next to receive the impulse. Now the processed impulse will be transferred to the motor neuron, which takes it to the effector organ, which is the muscle in this case. And that's what generates a response. And this complete process, or the diagram, as you can see, looks like an arc. Hence we refer to it as the reflex arc. The reflex action is one of the most important processes that helps save us from dangerous situations which may not be noticed by us. Now that you know about the spinal cord's role in saving our bodies, let's look at the structure of the brain, the organ that governs our body in detail. We will also study the various parts of this miraculous organ in our next video.